What's up everyone, Patrick here, welcome back. Moving on to the next example, dealing with trigonometry. So given this isosceles trapezoid below, we have to find the measure of all of the interior angles. Now, a couple of things I want to make a note here is the reason why this is an isosceles trapezoid is because if you notice, this side and this side are the same length. Okay, this dash through both sides means that both sides have the same length. So this side here has a length of 16. That means this side here has a length of 16 as well. And then another thing I want to mention is that these arrows here, if you see these arrows like that, it means that this side and this side, they're both parallel. And just in general, when you're dealing with an isosceles trapezoid like that, so let me draw it out here without all the other stuff on it. If this and this are the same, then this and this are parallel. What that means is that this angle and this angle here are actually the same, right there. And then it also means that this angle, let's call it alpha, and then this angle, let's call it alpha as well, are the same. All right, so if we can find one of the angles of this isosceles trapezoid, then we automatically get two of them. And then we know that all the angles, because this is a quadrilateral, they all have to add up to 360, then it's really easy to find the remaining two. Okay, so we really just have to focus on finding only one of the angles, and then we're all good. Now, notice that we're given the length of this side, 16, we're given the length of this side, which is 20, then we're also given the length of this diagonal over here, which is 22. And so notice that that creates a triangle within this trapezoid. We have a triangle right here that has all three sides. Well, that means that we could solve for any of the three angles. We could solve for this angle if we wanted to, this angle, or this angle in that triangle. And which of the three is the best one to solve for? Well, notice the best one to solve for is this one. Because these angles, if we solve for one of these, it still doesn't give us that full angle right here. Okay, if we solve for this, it doesn't give us this full angle. It's kind of like split up, and it's not necessarily split directly in half. And then this one here, it's not going to give us that full angle. But if we solve for this angle, notice that that gives us one of the full angles of the trapezoid. This is going to be theta right here. Okay, so once we solve for that angle, then we got this angle, and then it's easy to solve for the remaining ones. Okay, so we could solve for that angle here because we have all three sides of this triangle, of a non-right angle triangle. So let me actually redraw this triangle without all the other stuff that's going on with it. So we're solving for this angle theta. This is 20, this is 16, and then this is 22. And so we could set up the cosine law. Remember, on the left side of the cosine law, if we're solving for an angle, we have to have the opposite side of the angle we're solving for on the left side. So we'd have 22 squared like that, and then we'd have 16 squared plus 20 squared minus 2 times 16 times 20 times cos theta, like that. Right? And now notice we have an equation with just that theta to solve for. So we could bring the 16 squared, 20 squared over. So we'd have 22 squared minus 16 squared minus 20 squared, which is equal to negative 2 times 16 times 20 times cos theta, like that. And then we could divide both of these sides by negative 2 times 16 times 20, like that. So this would be divided by negative 2 times 16 times 20 in order to get that cos theta by itself. And when you do that algebra, the numerator you would get is negative 172. The denominator would be negative 640. Dividing these, the negatives cancel out, so you get a positive ratio. And then if you want to get the theta by itself here, you got to cos inverse this ratio that you get. And when you do that, you'd get approximately 74.4 degrees, like that. So that would end up being theta. That's this angle over here. And at this point, we are actually pretty much done or at least we don't have to use any sort of trigonometry anymore. Okay, because here, let me erase this. Remember this angle, as I explained before, they are the same, like that. And then these two angles here are the same. Let's call it alpha, right? These two angles alpha. And we know, so if we know that all of these angles added up have to equal 360. So that means alpha plus, sorry, let's put 74.4 here. Let's be a little bit more exact. So plus 74.4 plus 74.4, right? Those two angles have to equal 360. And so solving this, alpha plus alpha, those are like terms. So we could say 2 alpha right here. Then these added up would give you what? 148.8. That's going to be 360. Bring the 148.8 over, so you'll have 2 alpha is equal to 360 minus that, which would give us what? 211.2, like that. Divide both sides by 2. We get alpha equaling 105.6 degrees, like that. Right? So that means that this here is going to be 105.6 degrees. That means this here is going to be 105.6 degrees as well, like that. And all 4 angles add up to 360. All right, so we only had to use the cosine law once to solve for this initial angle here using that diagonal and then these other sides that we were given. But then once we had that, it was equal to that angle. And then those two angles, those two remaining angles, we could solve for with this equation that we made. And that's all of the interior angles for this trapezoid. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.